guys, this is Mrs. Bell. I'm going to walk y'all through DIY number 7 today over density of an unknown. Make sure you take notes as you go along. There's a couple of guided practices at the end that are really helpful to write down. Alright, substances have unique densities, just like you have a unique social security number or lunch number or school ID number that we can identify you by. All objects have a unique density assigned to them. If you can find the mass and volume of any substance, then you can also figure out what the density is and what that object is made out of. So for example, we have this density chart over here to the right, where it has a bunch of listed densities for different types of metals. It does not matter the size of the object, it only matters what the object is made out of. So for example, all aluminum, as long as it is pure aluminum, will have a density of 2.7 grams per centimeters cubed. Alright, so let's review a little bit of information about how to calculate density before we start identifying unknowns by their density. So we have our formula triangle with mass at the top and density and volume at the bottom. Density units can be grams per centimeters cubed or grams per milliliter. It all just depends on how you find the volume. Mass units are grams, and those are found by using triple beam balances or scales. And then volume is centimeters cubed. It can be found using the mathematical equation length times width times height for regular shaped objects. Or we'll use milliliters if it is a liquid, or it is found by using the process of volume by displacement. The formulas that we are going to be using today: density equals mass times volume, mass equals density times volume, and volume equals mass divided by density. For this last one, because it is division, the order matters with this one when you put it into a calculator, so just be careful. Alright, guided practice number 1. We have a cube. This cube has a side that measures 5 centimeters and has a mass of 1,100 grams. What substance is this box made out of? If they're going to ask you for the type of substance based off of a density, they're going to provide you with a density chart like the one from before. This is the same exact one. Alright, so what do we need to calculate density? We're going to need a mass, which they give us that in the problem, which is really helpful. And then we need to find the volume. They don't outright give us the volume, so we're going to have to calculate it using length times width times height. Because this is a cube, we can use that mathematical equation. So 5 times 5 times 5 equals a final volume of 125 centimeters cubed. Alright, so now we can take those two numbers and we can plug them into the density formula. We have mass divided by volume. So we're going to have 1,100 grams divided by 125 centimeters cubed, which comes out to a number of 8.8 grams per centimeters cubed. What substances in this chart have a density of 8.8 grams per centimeters cubed? You can see that it matches up with nickel. It has a density of 8.80, but both of those numbers are exactly the same. They are equivalent. The cube is made out of nickel. We just identified what that substance was using a density chart and calculating its density. And we're going to do one more guided practice. This one is a little bit different because it's not a regularly shaped object like a cube. This time, it's going to be a rock. It's called irregular. So in the graduated cylinder, we originally have 150 milliliters of fluid. We're going to say it's water this time. When we put the rock in, it goes up to 108 milliliters. We'll use those numbers again here in just a little bit. This rock has a mass of 252 grams. What substance is this rock made out of? So we have our density chart, and we're going to start calculating density. Alright, so to calculate density, we need the mass. The problem gives us that. It is 252 grams, which is really nice. And then we have to calculate the volume. It doesn't outright give us the volume, so we have to calculate it using the after volume read on the graduated cylinder and then the before volume read on the graduated cylinder. So we're going to take 180 milliliters minus 150 milliliters and end up with a final volume of the rock being 30 milliliters. So now we have our mass, now we have our volume, we can plug it into our density formula. 252 grams divided by 30 milliliters. That gives us a density of 8.4 grams per milliliters. Now, in this chart, you can see that the density is in the unit of grams per centimeters cubed. That's not a big deal because they are exactly the same. So what substance has a density of 8.4 grams per milliliter? It is brass. So this rock is made out of brass. We've now covered both of the different ways that you can identify a substance by its density. If you have any questions, make sure to reach out to your teacher. If you need to re-watch to take notes, you're welcome to do that.